This is our last panel, Innovation and Society, how to advance towards their integration. We have three panelists in this panel: Alba Nogueira from the University of Santiago de Compostela, Elena Andrade, a professor of the University of Santiago de Compostela too, and we also have Noelia Vilar from FEUGA. We start with our first panelist, who is going to talk about legal challenges, Alba Nogueira. She's a professor of administrative law. And Alba, you have the floor and you can share yours. Welcome to this last panel. Hello, good afternoon. I'm going to try to share my screen. Can you see it? Okay, so no problem, right? I would like to remind our guests that they can activate English to listen to the speeches. Okay, so good afternoon. Thank you very much for inviting me to this workshop. And I think we are going to change completely the topic because I'm going to talk from a legal point of view. But we are also maintaining the connection point of talking about circular economy. The idea that I wanted... So this topic is right now in the spotlight. No doubt. This entails a change of paradigm. That is to say that this linear production that you can see right at the bottom, extraction of resources, production, distribution, consumption, and waste. We had to turn all these into a continuous process, and law has to accompany this change through proper regulations so that we can use fewer materials and so that we avoid the production of waste. So I'm not actually just keen on the circular economy because it would just change the old law on waste for another one. We have to change our paradigms. To this end, we have to provide some environmental context data. This data shows the urgency, shows that we have to change our paradigm right away. We have to change how we behave as consumers in society. We have to change how we consume products. Within a 50-year period, the ecological footprint went up to nearly 190%. Raw materials increased considerably between 2017 and 2019. However, the level of recycling is just 8.6%. Therefore, we have a very, very low level of recycling and reutilization. This slide shows two graphs reporting data from both the EU and Spain that have surpassed the planet limits on different issues. And right now they are at a very critical point. Therefore, we can connect this to this topic. What's the circular economy and how law can actually accompany this process? The Spanish strategy for the circular economy 2030 seems to show the way. I'm going to be, however, critical as to how this is being addressed by the EU, the Spanish government, and Galicia. I mean the way in which we understand society and the economy. So this headline reads that the circular economy is intended to concentrate efforts at the beginning of the chain, and that's critical during the design phase in order to achieve product durability, fighting obsolescence, and fostering their recovery, recycling, and reprocessing of components. Thus, the final cycle stage will require fewer efforts as the economy becomes more circular. So the key here is not only to consider law provisions but also technical aspects. We have to see how we can help manufacturers, producers, and farmers so that they no longer use consumption models that will eventually result in high volumes of waste, but rather we try to make the production model restrict the number of materials used, or this production model actually optimizes the consumption of water, other materials, and so that the consumption model can provide for a longer life cycle of products while incentivizing a recovery process, for example, substituting or replacing parts to avoid the lowest disposal of waste possible. So this change would cause or would result in many positive outcomes. It would reduce pollution, environmental impact, etc. Nonetheless, as part of the circular economy plan launched by the EU in 2015, in 2020, a second one was launched. A number of ambitious targets were put forward, but we see sort of a gap between both of them. Because as you can see in the second column, there's one key component. The European Union and Spain had placed their odds on fostering the circular economy, but using documents that have no regulatory value. So neither the EU nor the Spanish circular economy documents are actually legal documents. They are not documents with a legal status. All the provisions and regulations that have been put forward in Europe on the circular economy are only limited to waste management. Since 2015 to date, we know many reforms on packaging or on the disposal of single-use plastic containers. We also know about the new regulations on fertilizers or the reutilization of water. But we are at the very last stage of the cycle, and there are only however, there are some amendments to the laws on consumption, even though they are just limited. And there are also some amendments with regards to design, but they're also quite limited because the eco-design standards are only applicable to energy products, that is, products that use energy. And in addition, a number of modifications took place during 2019 and 2020 with regards to eco-design standards, leaves durability of products aside or overlooked. Let's just say here we're talking about implementing measures in order to avoid or to lengthen obsolescence or make sure that products can last more. It's true that the obligation of having replacement parts available for some time is mandatory. That's quite an advance, but the products repair processes are only limited to authorized installers, Therefore, this is only limited to independent installers or repair individuals that actually have difficulties in carrying out their activity. So green public procurement has not been improved because it continues to be voluntary. There's no circular fiscalization, and most measures are voluntary and not mandatory, and I believe that this entails a problem. In the case of Spain, if we take a look at the Spanish strategy on the circular economy, we see how a number of targets have been put forward that may seem adequate at first sight. But then we read that these targets should be understood as indicative targets in the next decades. They are not going to be binding because they are not actually set out in the relevant regulation. So as you can see, it's quite contradictory. We have some targets that have been set out, however, there's no clear idea about them. So they're just written down in a piece of paper, but they are not actually enforceable. We remain therefore applying this regulation on products, and we have different problems that show how compelling it is to start applying eco-design actions. So the reduction of greenhouse gases show how some sectors, such as, for example, aviation or the maritime industry, make a growing contribution. That is also the result of a certain way of consumption that is certainly unsustainable. If we produce thousands of products in China of little value, and if they are carried by plane or ship to be consumed here, it's pretty evident that such products are not circular products because they use a lot of energy and produce a lot of gas emissions. Besides, there are certain raw materials that are critical and that we are actually throwing away into dumps. In addition, that they end up in landfills. We have another problem, and that is that we have to examine if we export waste, they have to be posted as a deficit of circularity. In fact, certain barriers are being imposed by third-party countries such as China that are putting restrictions to waste export, and that triggers some signals showing that we have to change the chain. So in order to have more durable goods, we need eco-design standards for more sectors, not only for energy products that penalize scheduled obsolescence. And here we can see some examples. France, for example, will penalize scheduled obsolescence with a 2-year fine, and they will introduce a reparability index so that when people buy products, they know how they compare against other products in terms of durability. However, other changes are required as well in other areas, like, for example, with regards to brand patent. This shows to which extent the circular economy clashes with some elements that prevail in the way in which we understand society and in the way in which we understand things. So the news about Apple is quite illustrative, because Apple fought all the way to the Supreme Court of Norway against an independent repair company that used to repair iPhones and screens. Maybe you wonder why such a multinational as Apple goes after an independent repair company. Well, because that company was importing from Asian countries certain telephone parts that Apple, on which Apple has patent rights. Therefore, by or when introducing or using them in mobile phones, they considered that this was a breach of their brand rights. So the Supreme Court of Norway passed sentence in favor of Apple, and now the Apple name has to be displayed in any part used in telephones, regardless of whether they're visible or not. So this will somehow cause a change in industrial property regulations as well. So we can act as the Supreme Court of the United States has dictated in the face of a lawsuit or a claim by a company. In this case, we're talking about a company that produces ink toners. Independent companies are used to refill their cartridges with an ink other than the one produced by the brand, were somehow infringing upon patent law. Besides, they were also introducing cartridges from other countries. So the Supreme Court of the United States said that the patent is no longer valid once the cartridge is used. So if businesses want to refill cartridges in order to take advantage of the cartridge, they are allowed to do so. So there are two different ways of approaching the matter, but this shows to which extent the circular economy can actually clash with other aspects that have to do with our economic system and society's views. This is another example showing how the eco-design provisions, flexibilization regarding washing machines or refrigerators. In the first version, all devices were supposed to be ready for assembly and disassembly, but the next version stated that they had to be disassembled in order for recovery. So and that would cause the product to lose value when reaching the very last part of this chain. So we have to render products more repairable and durable. In the case of refrigerators, we see how the early versions in the revised eco-design regulations stated that information had to be provided, including information for independent repair companies. However, the final text speaks about professional repair companies being the only ones authorized. And in closing, all this should be accompanied by other measures that are an incentive to avoid waste from to avoid materials from being disposed of as waste. So I believe that it would be much more interesting to draw fiscal policies in order to promote reutilization. In Austria, for example, VAT reductions are applied for small repairs on bikes, clothes, shoes, etc. The same happens in Sweden, so that could be a critical measure. In closing, as I mentioned before, we have to change our way of consuming products. We have to produce repairable and long-lasting products. We have to do a shared use of goods. We have to change regulations both tax and information regulations. For example, if we are going to buy a drill to just hang three frames is useless. We should be able to actually just rent a drill for that task. So we need tax and other regulations in order to regulate that, taking into account the scheduled obsolescence and other best practices in using products. So that way we will be able to guarantee recyclability. This is something that we insist on again and again. This doesn't have much to do with the circular economy. Actually, this renders the concept of circular economy even more obsolete, and that's the end of my presentation. Thank you very much.
Thank you very much, Alba.
Thank you very much for touching upon all the legal challenges that we have to address in building a circular economy. Now we are going to give the floor to our next speaker. She will share her presentation now. Elena Andrade will speak about the social challenges. She belongs to the COSOYPA Group from the University of Santiago de Compostela, and Elena Andrade holds the chair of behavioral methodologies. So, Elena, you have the floor. So, thank you very much. I will now share my screen. And my presentation. Well, thank you very much for having me. Angela has already introduced me. My name is Elena Andrade. I work on behavioral sciences in the University of Santiago de Compostela. My department includes social psychology, basic psychology, and methodology. Together with other colleagues from social psychology and methodology, we have formed a research team called COSOYPA that since 2015 has built a great connection with another research unit in the University of Santiago. We work with CRETUS. This is the English acronym. It was not very easy to choose a topic to discuss at this address. So I'm not going to tell you now a story. I will just talk about a real story, something that happened over the past years. And I'm going to follow a chronological order, and I'm going to conclude touching upon one of the projects that we are running under the framework of the Conserval project. I should say that some of the data that I'm going to share with you are connected to some projects in progress and with some thesis work in progress, so I will try to be very careful. Psychologists study the way of behaving and thinking that people have. Social psychologists pay special attention to individual behaviors in the context of other individuals' behavior. So the description of the excessive use of water or waste generation, atmosphere emissions coming from transportation means, etc., that is something that we share with other sciences. So here we are trying to identify how, why those situations arise and how we can change patterns. So we want to change people's behavior. So what's the challenge that we have? We have a single challenge. We want to build some kind of healthy and behavior based on solidarity. So doing some kind of words here. Of course, we want to reach the zero pollution goal set out by the EU by 2050. And here, what I'm trying to say is that over the past, in the next 10 years, these actions mean that we will have to support zero pollution generation in cities, reducing health inequalities, reducing environmental degradation and pollution, and also individual behaviors. For example, we have to avoid water, air, and soil contamination, and this is also concerned with more sustainable consumption behaviors and a truly collective change. So, zero pollution means, whenever we can start thinking about zero pollution, this means that we will have to change our behaviors. All these aspects that you will see throughout my presentation could make up this circular economy strategy applicable to any region. So based on political decisions that may be made at a national, regional, or international level, we can contribute some data that are perfectly aligned with this strategy. The latest report of the UN says that in general, world populations are being redistributed. So cities play a critical role to sustainable development. By a sustainable city, we mean something that is not defined by a single indicator. I would say, or researchers, many professionals and experts would say that at a macro level, this is concerned with the entire population, and we would find indicators in this triple pillar made up of urban sustainability, environmental, and economic aspects. It was lucky enough to be involved in a project within the scope of Kratos that was aimed at identifying some indicators that would enable us to define or characterize the sustainability of cities. So based on some preliminary work that covered 31 cities based on 38 metrics, taking into account environmental, economic, and sustainability aspects, and using classification trees, we chose those metrics, the minimum number of metrics possible, in order to characterize cities' sustainability. So we tried to answer which sustainability metrics could be identified prior to the pandemic at a social level. Well, for example, the number of kilograms per inhabitants. Another element would be female unemployment rate. So the most relevant indicator was the global unemployment rate in cities. Curiously enough, and from an environmental perspective, it turned out that the most important urban sustainability metric was the municipal solid waste produced per inhabitant. So by using these three indicators, we can characterize, or we can actually determine the efficiency, or we can better classify cities into sustainable cities and non-sustainable cities with an accuracy of 87%. We also try to set the thresholds of all these indicators. So in the case of female unemployment rate, we determined that if in excess of 14%, it was quite unlikely for that city to be considered sustainable. 16% corresponds to the global unemployment rate, and as for municipal solid waste, 423 kilograms per inhabitant and per year would set a change in the possibility of classifying cities into sustainable or non-sustainable. This graph shows this environmental indicator that we call MSW, and then we have other graphs for other indicators. So by using these three indicators, we can come up with an early assessment of cities, notwithstanding any other thorough examination of additional variables. Now, talking about people, we know that people behave in a certain way. Now, how can we make sure that people consume less or they produce less weight. We analyzed this as part of our project as well. In the case of water, in order to promote the reasonable and responsible use of water, we need regulations. We also need information campaigns and also awareness campaigns and also feedback. This seems to be a broad concept. We can say that perhaps this indicator was the one that reported the best results. All these initiatives mean that society needs to be acquainted with any water-related issues and also hold a positive attitude towards preservation and conservation. When talking about a positive attitude about conservation, we also analyzed this in the urban context of the Galician region. Citizens themselves during individual surveys answered that, the answer should be no, that a better attitude or more knowledge do not lead to a more responsible use of water. Here we are talking with context where there is no restriction in water consumption. In other cases where water is not actually available in high volumes, the situation changes. Here we are talking about an area where there's a lot of rainfall. But what happens in the case of areas that have a propensity towards droughts? For example, we had some very hot waters with some shortage of water in the region, and that changed the results. So under such circumstances, we need to know where to start. Well, we know that in general, people do not have much information mainly about water resources. That is to say, our population hardly know about the origin or the source of or where the water they use in their households comes from. On the other hand, here we have a regression model. This knowledge is directly proportional to the fact that the respondents were females, students. This is in line with a conservative political ideological approach, and also it's also related to a misuse of water. There is sort of incoherence between the conservation attitude and actual behavior. In this respect, models have not predicted that much concerning a change of behaviors. So we need to make efforts, such as, for example, focus more on conservation and consumption, and we also need to focus more on the development of technologies. We see that there are different technologies that can be used in order to better use water, recycling, etc. So in this respect, there are always some developments that have been checked and that arise systematically. In general, in the case of low contact water use, for example, when water is used for firefighting or for golf clubs irrigation, they are normally affected by a high percentage of the population. In the case of high contact water use, these are normally related to some emotional or some distressed situations. For example, when recycled water is used for farming or for drinking and cooking. Temperature. The literature also has many examples about sustainable solutions that, however, are frowned upon by the public. We did some research in this field, and we observed that on the one hand, our population is not very knowledgeable about all this, but we also see that users and consumers sometimes have a misconception about water use. That's why this study about science and society was so interesting. We also tried to collect ideas about the technologies that could be used in wastewater treatment plants in order to recover wastes to produce fertilizers. We ran some focus groups with people that work in this kind of facilities, ecologists, and other general groups from the population at large. We came to the conclusion that in many cases disadvantages were pointed out, but also some advantages. This slide shows those that were mentioned more frequently. Focus groups, therefore, reported these advantages and disadvantages more commonly. As for disadvantages, and this is the number one disadvantage that you see here, because this is mentioned again and again, there is apparently sort of a misconception about any water-related problems or problems resulting from water shortage. Also, protection, the environmental protection. Other aspects were also mentioned, but to a lesser extent. As for technological innovation, people are asking for or technology is asking for a different way of behaving. Of course, this is not easy to attain in our immediate context, and it will only be possible once drivers or all the advantages are greater than the disadvantages. Which variables could actually be used in order to assess private projects and eventually implement them? My apologies. So far, I have been speaking about the diagnosis framework. We won't not be able to change people's behaviors unless people recognize that there is a problem. In the case of water, it's pretty clear. On the other hand, people also need to feel the threat of water shortage, and on the other hand, in the case of water, this is pretty clear. There should be some identification of responsibility. So once we have overcome this phase, and should technologies allow so, to say, provided that there is some background technology, we can start talking about written or unwritten regulations between people, social standards, or for example, those that are concerned with most frequent behaviors, or those behaviors that are expected from us. Well, that are expected by our peer groups. For example, by belonging to a certain group, we resemble the other individuals in that group's behavior. This is also tied all together, as you can see in this chart, with the perception of our capacity to act, and also with the cost and benefit analysis of all the actions that we need to take to implement change. In the case of water, and I don't know whether you can see that, this cost also has a risk perception component, a risk to health in the case of recycled water, and we can also see that if there is trust in technology, that trust in technology can lead to a lower risk perception, and eventually that can show environmental benefits more clearly, and therefore making people accept recycled or reclaimed water more openly. All these variables have enabled us to build a prediction model to determine how likely people are to accept the use of reclaimed water. It has proven to be quite useful. It has been extrapolated to different regions for different types of use, both high and low contact use. Of course, risk perception will be different in case of using water for one purpose or the other, but this model can be all the same extrapolated. Nevertheless, this is a cross-cutting analysis of information that, just like in chemistry, means that we have to go to the lab and test why we have certain variables prevailing over others, and why reclaimed water is sometimes accepted and sometimes not. The Conserval project encompasses a number of challenges which are similar to those in the Conserval project. This is connected to a specific sector. So here we are trying to use, for example, the wastewater flows from the canning industry. In this case, we're talking about VFAs, or high added value products. VFAs, oils and proteins should come or should reach out society directly from industries. In our case, we have decided to assess the perception of technologies applied to productions by going through two stages. On the one hand, once we have defined the main products and markets, for example, for the chemical, pharmaceutical, and canning and food industries, we have put together some focus groups made up of consumers from all those sectors in order to get their insights. So based on those insights, we will be able to understand the cognitive and emotional elements that are involved in accepting or rejecting these products. We also want to highlight shared behaviors and those that are subject to controversy. In stage 2, we are going to select samples. We will do some sampling, and we will apply questionnaire in order to assess all the variables involved. By assessing the data, we will be able to measure the relative weight of all barriers to accept these technologies and products. Eventually, we will be able to prepare a communication plan. So this communication plan will be targeting the uses of technologies and products, and this will be our contribution, our humble contribution to the circular economy, to sustainability, and why not to increased harmony in our relationship with nature and the environment. Thank you very much. Thank you very much for your time. Elena, thank you very much for sharing your presentation with us today. And now we are going to give the floor to our last panelist, Noelia Vilar. She is the Technology Transfer and Innovation Manager at FEUGA. She will speak about the transfer challenges. So you have the floor.
Whenever you're ready, Noelia, you have the floor. You can share your screen now. Thank you very much, Angela. Welcome. Thank you. Can you see my screen now? But I think I need to use the full screen, right? Okay. So, can you hear me, right? Okay. Let's start. As I am the last one, I will try to be quick. And first of all, good afternoon. I would like to thank the organization for giving me the opportunity of presenting a first summary of the challenges within the circular economy of waste and resources transformation. As we've been talking during this workshop, there is a huge interest on achieving sustainability in circular economy. We are looking for a transition from the current model where waste is we need to move to a circular economy model. And in order to achieve this objective, innovation is key. Developing new technological approaches to minimize waste and to add value to the waste generated. Technological transfer is essential to implement new solutions in the current production and distribution systems or management systems in a sustainable way. If we try to explain what technological transfer requires, we should say that it needs to analyze the different sectors that will be related with this technology. So we need to analyze the providers, the adopters, and the users of this technology and of the final product generated in order to find the best model to transfer innovation. In general, during a technological transfer process, we need to analyze the state of the art on industrial properties related to that technology or its scalability or tech robustness. The fact that a technology has a design that can be scalable to other industries or that it has solid results will increase the successful probabilities, the probabilities of success. Also, we have other companies doing the same, and this is something that will help to define the entry into the market of that technology developed. Finally, we need to take into account the final users. We need to research the scenario to find the best exploitation channels and commercial advantages, positive effects for the subsequent use or implementation. Then, taking into account the challenges that we find on technological transfer based on this context of circular economy, I would highlight 3 areas. First, we need a technology to be transferred that has to be solid in order to give positive results at industrial scale. It has to be independent from the variations that can appear on the sector. And for that transfer to be effective, the design of the technology and the transfer of knowledge need to be appropriate. So the sector where it's going to be implemented can have a easy use of that adaptation. For instance, with technological transfer, we are looking for the detection of the borders from a technological point of view to tackle those needs before implementing it. And this is very important. Also, in the technological transfer process, we pursue a collaborative economy. We need new business models involving the whole society for a positive impact. And we need collaboration between all the stakeholders and sectors involved, because the administration needs to be related with the distribution, production, and final users for a complete transfer. The sector to which this new technology is addressed needs to have synergies with other sectors, because sometimes they may need government support or a different logistic distribution. So everything needs to be linked for a better transfer. And finally, to develop new exploitation channels that are efficient, efficient market research needs to be conducted. We need to assess the entire competitive environment to get an idea of how to increase the competitiveness of the company or the industry where we want to implement a new technology, at the same time that we increase its sustainability. I would like to talk also about these three pillars, but applied to the evaluation or valorization of waste. As we already mentioned, innovation needs to have a great potential and a good level of maturity, so it can really be implemented in the target sector. For example, we have a technology that has been used for many years, but the introduction of a new technology needs to be disruptive because it needs to show the advantages for its target sector. Then, in the specific sector of this valorization of waste, we need to have a viability in the process. In circular economy, we would transfer specific product to a with a technology. So there are borders on the design of the production lines, the existing ones. So we need to overcome those borders before transferring the technology, because this is going to impact the economic feasibility of the project. In order to transfer the economy, we need to see that there will be economic profits. If not, the company will not have its implementation aligned with the profitability of the company. We will also need to take into account the specific characteristics of these byproducts, because the results may be different on the final product for the company. When we talk about byproducts, we never have something standard. It depends on the type of the company, on its size, on the byproduct itself, on the amount. It may be a seasonable byproduct, for instance. So all of this needs to be analyzed before transferring the technology, and we need to overcome the barriers first. Also, if you want to give more value to a product, you need to take into account its yield. The new technology needs to have a good yield for the user of the new product to use it in a way that it can replace the existing product. As for the collaborative economy in this transfer process, I would highlight that in the circular economy context, we are looking for business models that include the collaboration among different sectors. We want multiple impacts on the environment, the society. So we will look for collaborations between sectors based on technology and results, so the technology transfer is successful. In this case, when we talk about the valorization of waste, we need to involve those generating the waste, the managers, the transformers, processors, and the stakeholders. So we need to take into account different points of view and needs of each sector for this transfer to be effective. And finally, as I already explained, the market research is very important. Applied to this concept of waste valorization, a market research of the technology itself can be made, but also an analysis of the market of the product that will be obtained after the valorization. In other words, we will have to analyze to whom this technology is going to be transferred and how, We need to see if there are other similar technologies, if there are opportunities for collaboration. We need to understand and study the market of the final product too. We need to assess the advantages and threats against the already existing technologies. We will need to analyze the prices, the availability, compare the products, the already existing products, and see if they are sustainable throughout the time, the market chosen, and of course the situation of the clients. As Elena already explained, is a very important part for this transfer to be completely effective. And also we need to see if there is demand for this product. I would like to give you some examples of all of this from the implementation point of view, how we are implementing this technology in the Conserval project in this case. I'm going to summarize the objectives and challenges that we found from a transfer point of view, technology transfer point of view. So Conserval aims to valorize the waste from the canning industry and create new added value products with different uses for the chemical industry, for the food industry, by using and implementing a new technology and new process optimization. The outcomes expected from this project are to improve the industry's competitiveness, new market opportunities for those byproducts. And within this framework, we could summarize the challenges as technical feasibility challenges. We need to take into account how to implement these new technologies developed on the canning sector. We need to consider the location and size of the canning factories. Also, the availability, characteristics, and volume of the feedstock. We need to analyze all of this. Then we need to integrate this technology in the best possible way, in a profitable way for the sector. There are regulations and legislations that need to be taken into account at this point, because we are working in the food sector and it has so many regulations to be assessed before transferring this technology. And finally, a market research. We are going to analyze our competitors at the technological level and also at product level. We need to check if this product if there is a need for this product and if it is accepted by the society. Once we have all these challenges solved, we will be able to implement or to carry out a technological transfer in a successful way. So to summarize my intervention within the scope of circular economy and waste revaluation, promoting a circular economy to be reached completely in the next 10 years, we need to analyze the three sectors that impact the most, which are the technology and how these reevaluated products will work. The main challenges are to establish intersectorial, cross-sectorial partnerships and to have products that are acceptable in the market. Thank you very much for your attention. If you have any question, please don't hesitate to ask, and you have my email there in case you want to send me any information or question. Thank you very much. Thank you, Noelia, and thank you to the 3 panelists who have spoken on this last panel. As we don't have much time, what if we start with the questions and answers? And we start with the first one. Noelia, if you can stop sharing your screen now. So the first question is on the in our chat. It was made some time ago, and it comes from Álvaro to Isidro from Sogama. And Álvaro says, is there any use for the ashes? Is there any circular purpose for the ashes in the electricity generation plant? Well, we have the waste, 2 types of waste. One is the slag, and the other are the ashes. The slag is used. We withdraw the metals and glass, and we use it for roads, cement. So there is no 100% use for it especially because of the crisis in the construction sector. But yeah, we use it. And then for the ashes that are the volatile part that comes from the boiler, the legislation does not permit to revalue these ashes. The European Union lets you revalue the slag, but we cannot reuse the ashes. We can only store it in a controlled dump for ashes. There is no plant or premises. There are no premises in Europe doing that. I hope Álvaro got an answer to his question. And then we have a second question for Elena and Alba. How can we address the regulation changes for them to be well accepted by the society? And thinking about this industry of cheaper products and that last less, especially when we talk about mobile devices, for example. So how can we tell the consumer that due to these changes in the regulations, the prices of these products will be increased, but they will last longer?
Okay, in answering your question, perhaps according to the knowledge we have on this matter, and to provide more cohesiveness, as far as we know, we have to use proximity variables, but actually change is triggered when you become aware of the problem. So that is the key. Right now, we are analyzing the acceptance of recycling technologies and waste-to-energy production technologies. We are checking whether we have a diagnostics problem, whether we have a framework problem, or whether perhaps society is not aware enough of the need to lengthen the life cycle of products. So this is not being currently discussed, nor is water shortage, so that's where we would have to step in. It all depends on the stage of the change process we are talking about. I don't know exactly which is the general public opinion about this. I know that it's being discussed, but perhaps not enough yet for people to be positively predisposed to buying more expensive products, provided that they last longer and therefore are more sustainable. With regards to regulations, not are always well accepted by citizens, but I believe that this question is about whether society would be ready to embrace new regulations. I couldn't dare answer at this point. We would have to first analyze which the current status is in the face of this topic. Okay, with regards to Miguel and Mauricio's questions, I believe that the answer can be provided from different perspectives. On the one hand, we speak about obsolescence, called scheduled obsolescence, or the durability of products. And products are specifically manufactured so that they are no longer useful as of a certain point in time. Sometimes chips are embedded into products to that end, or updates are required, as it happens with phones. Unless those updates run, telephones function very slowly, and eventually they do not function any longer. So how can we tackle this? Well, France penalizes those manufacturers that produce and manufacture products with a certain expiry date. So it's a pretty easy solution. Other ways of addressing this problem? Well, regulating eco-design, setting out new standards on products. We have thousands of such standards. So whenever we have a new product, we know, for example, which substances cannot be used. For example, in the case of children's toys, toys cannot contain any toxic plastic or small pieces that kids could choke on. It seems that our speaker has lost her connectivity. We're back. So we should take into account the legal guarantee period of products according to regulations, and according to that, but according to those regulations, for example, the guarantee period means that users have two possibilities: to return the product or get it repaired, but it's an alternative. We could change the consumption provisions, stating that companies should preferably repair the product, and only if not possible, they should replace it for a new one. So that way products could have a longer life. As to other types of obsolescence, as Miguel said, people like new things. We like having new things all the time. For example, we like wearing tight or skinny trousers, then white trousers, etc., etc. So we are constantly being given new features and alternatives. We always want to have the latest mobile phone, etc. So this is what we call psychological obsolescence. And this can also be tackled through pricing. These products are used because they are inexpensive, but also because not all related costs are charged. For example, if a garment is manufactured in Vietnam, then it has to be transported and over the ocean and be sold at 10 euros, it means that transportation costs are not being charged to that garment. So perhaps we should integrate costs, transportation costs, into the final price, the cost of the waste produced. So, for example, if the waste of producing a garment accounts for a certain percentage, perhaps clothing should start including all those costs into the final price. That would be a good idea or a good way to regulate how consumers behave with regards to psychological obsolescence. Well, thank you very much. For example, if I'm going to pay for my shoes to be renewed with a new sole, everything that has to be considered as a whole, so that we do not send contradictory messages to consumers. We can't say that we have to be more sustainable, but at the same time that you have to consume more in order to support the clothing industry. It's a contradiction. Okay, so thank you very much, Alba, for answering this question. We have a long way to go, no doubt. Thank you very much.